Hello friends, welcome back to my YouTube channel. So in today's video we will see one more problem of cantilever beam. How to analyze this by using the moment area method. So this is our given problem. Find the slope and deflection of the free end shown in the figure by using the moment area method. We need to find the slope and deflection of the free end by using the moment area method. So here this is the cantilever beam. Here one end is free. It has a 10 kilonewton of point load. Here also 30 kilonewton point load. From A to B EI is 4I and from B to C EI is 3I. First we need to find the support reaction of this. So here we need to find from this side to this side. I will go from right to left side. Now we need to find the bending moment support reaction. Here bending moment at support reaction will be 0 because this is having the free end, no? So BM at point C will be 0. Now we need to find the bending moment at point B. So MB call it as. So now we need to see only this much of portion. Here point load of 10 kilonewton is acting. It is moving downward. So minus 10 into, at the distance of from here to here is 2. So minus 10 into 2, if you do, it will come out as minus 20. Similarly, we need to find the BM at point A. BM at point A. So here 10 kilonewton is acting. So at a distance of, now we need to see the here to here. At a distance of 2 plus 2 is 4. 10 into 2 plus 2, it is also acting downward, moving downward. So minus 10 into at a distance of 4. So sign convention you all know, no? Which is moving upward we need to take the positive, which is moving downward we need to take the negative. And here minus one more load of 30 kilonewton is moving downward. So minus 30 into at what distance? From here to here is 2 meter. Minus 30 into 2 is equal to, now solve it. So by using calci we will solve it. Minus 10 into 4 minus 30 into 2, if you do, it will come out as minus 100. So minus 100. So now we need to draw the DMD diagram by using this value. Here at point C, this is having the free end. No, at free end bending moment will be 0. Here it will be 0. At B we have the value minus 20. Minus means it comes here. It is 20. And at point A we have the value minus 100. Minus means it comes here. So now join the point load. We have the diagram. Bending moment diagram will be straight line like this. From here to here also it is again straight line. This is the BMD of, this is also negative, this is also negative. This is how we need to draw the bending moment diagram. So now we need to draw the M divided by EI diagram. So whatever the bending moment value we got, we need to divide this value divided by EI. We need to divide it. Here at point A, now we will go left to right. Here at point A we have the bending moment value 100. We need to divide 100 divided by EI value is 4. Here EI value is 4. Now we need to divide 100 divided by 4. We need to divide 100 divided by 4. We need to do, it will come out as 25. It will come out as 25. 25 means it comes here, 25 divided by EI. Similarly at point B we have the value 20 divided by 4 we need to do. So 20 divided by EI value is 4, no? 20 divided by 5 if you do, it will come out as 5. 5 divided by EI. So at point B we have this member is connected to 4 EI as well as 3 EI, no? That's why we need to divide 20 divided by 4 EI one time and 20 divided by 3 I. We need to divide it twice. One with the 4 I, once with 4 I and once with 3 I we need to divide. Because it is acting the middle, no? Now 20 divided by 3 if you do, it will come out as 6.66. 6.66 is nothing but, it will also comes here only, 6.67 divided by EI. Divided by EI. This is how we need to find the M divided by at point C no value. It is also 0. Now join all the lines. It will be like this, and here it comes like this, and again it joins here like this. This is how we need to find the m divided by ei diagram. So now what we have to do is what they have said. They said to find the slope and deflection of the free end. Now we need to find the slope and deflection at point C. Here at point C it has the free end. Now we will see. We need to apply the first theorem. So what it says, it is, now we need to find the slope at free end. Now free end means theta c. That's why we need to go from this side to this side. Theta c minus theta a is equal to area of m divided by ei diagram. So here mc, slope at c, if we do the elastic curve, I will show you, the curve will come like this. No, here at point A, this is point P. At point P our theta c will be maximum deflection. At fixed end the slope as well as deflection both will 0 at fixed end. Here at point A fixed support is there. Now at fixed support our theta a becomes 0. So now theta c has the maximum value. So now we need to find the area of m divided by ei diagram. So I will draw it separately here to find the area. So our diagram will be, it is like this. No, it is like this. If I divide this section into rectangular, and I will call it as the 1, this is 2 section, this is 3. So now we need to find the area of this rectangular and this one we need to find. Now to find the area of rectangular, we have the formula. To find the area, we have the formula L into HL is nothing but length into height. So here we have the 2 meter length, here also 2 meter. Height of this will be 5 meter. No, so here 5, here 6.67, here 25. So from here to here will be 5, here to here will be 5. No, here to here will be 5, and we know the total distance from here to here is 25. So now we are calculating the area of this rectangular. No, the formula is length into height. Our length is 2 meter and height is 5 meter. If we do, it will come out as 2 5 is 10. Area is 10. Similarly for A2 we need to find the area of this rectangle. For that we have the formula half into height into this length is 2 meter. No, 2 meter, and we need to find the, we don't know this much of height. No, for that what we have to do is, we have known that this total distance from here to here distance is 25. No, here to here is 25 means, and we have already known from here to here is 5. If we do 25 minus 5 we will get the this much of distance. 25 minus 5, if we do, we will get the 20. This much of distance is nothing but our 20. So 2 into we want this distance. No, this distance we got was 20. So put that value. 2 will get cancelled. Answer will be 20. And similarly for A3 we need to find. For that we have the same formula, half into length into base. Length is 2 meter, half into length into height. Height is 6.67 into 6.67. If we do, 2 will get cancelled. A3 will be 6.67. Now we got the A1, A2, A3 area of these all the sections. Now we need to put here A1 plus A2 plus A3. A1 is 10 plus A2 is 20 plus A3 6.67. If we add, it will come out as 36.67 is theta c divided by ei. Theta c is equal to 36.67 divided by ei. Clockwise, write the clockwise. Because all the areas the value will be negative. No, if you don't, when you don't want to put the negative sign here, just write here clockwise. Now what we have to do, we need to find the deflection at point C. Here we need to find the deflection at point C. Now for that we have formula delta C is equal to moment of m divided by ei at C. We need to find at C. At point C we need to find the deflection at point C. No. Now for that we have the formula. Our movement formula will be, what is our movement formula? So movement formula is area into distance of CZ. Area into distance. Now but we need to take the distance here. Distance of CZ we need to take here. So area already value we have calculated here. So formula will be A1 into x1 plus x1 is nothing but our distance of CZ, and A2 into x2 plus A3 into x3. A1 value we got was 10. No, 10. For that we need to find the x1 value. So I will show you here. This is point AB. It has the load of 10 kilo. 10. No, 10 will be acting at the center. Here we have the total distance. Here we have the total distance 2 meter. Here to here 2 meter, and for BC also 2 meter. Now we need to find the distance from CG. No, this is our point. We need to find the center. No, here also 1, 2 means here also 1. We need to find from here to here distance. Here to here is 1 and here to here is 2. 1 plus 2 will be 3. So our x1 will be 3. Similarly for A2 value is 20, and for x2, here point member AB has the two loads, one is 10, another is 20. 20 will be acting here at a distance of, see here, this is not acting at the center. It is not acting at the center, it is acting here. No, from we need to find the distance from here to here. Here to here means we need to take this distance, because we want to find the deflection at point C. No, that's why we need to take this distance from here to here. Here to here our CZ will be 2 divided by 3 into L. So 2 divided by 3 into L, we have the distance 2 meter. No, so into 2 plus we need to add this much distance. This much is 2. No, so now add it. It will come our x2. To find from here to here distance, we have the formula 1 divided by 3 into L. Now we want the from here to here distance, now, because we need to find the deflection at point C. No, that's why we are taking this formula 2 divided by 3 into L. Whenever you want to find this one, for that we have the formula 1 divided by 3 into L. So now solve it. Here 2 divided by 3, 2 by 3 into 2 plus 2, if we do, our H2 value will be 3.33. 3.33. Put it here, substitute here, 3.33 plus A3 is 6.67 into x3 value. Similarly for x3, the load is acting here 6.67 at a distance of, again, so at the distance of from here to here is 2 divided by 3 into L. At a distance of 2 by 3 into L is 2. If we do, so we will get the value 2 by 3 into 2. If we do, it will come out as 1.33. So 1.33. Now you can add all this. 10 into 3 plus 20 into 3.33 plus 6.67 into 1.33. If you do, the value will come 105.47. Deflection at point C will be 105.47 divided by EI. So theta C is 105.47 divided by EI. So it is downward. Because these values in negative, no, that's why we need to put here downward. So this is how we need to find the deflection at point C and slope at point C. Here our problem ends. So if you like the video, like it, share it and subscribe for the more videos. Thank you for watching.